this view. Hello. Hey, Bleep Track. Hey, Johnny. Hey, Christian. So, wait. Does it fetch YouTube already? Home Assistant. Check that. I see only. Yeah, I didn't update that header here. Here is that. Okay. So today, coding session. I must wait until the TTS catches up. Hey, Dutch Maker. People complaining about the hard thing on YouTube. I hate it as well. It messes with the automatic scroll and so on. Okay, so what we have is, maybe let me change. No. What is this? Yeah, we have snow here. Why don't I see? Oh, I used the wrong cable. Okay. Wait. This is the right HDMI cable here. Okay, so we have the mini console, which should be, yeah, and we fixed up. Where is screen capture? Screen capture. Okay. Why? What? Where is? Can I resize that? Resize, scale, blend more. Oh yeah, here. Here we go. Okay, so broken LED is still there, and yeah, bad apple. We have, I don't know how many frames it is. This is like uncompressed right now, and we have 14 kilobytes of memory. "15 centimeters." Yeah, I saw you have like Sweden is completely buried. Hey, Larry. Frame to frame completion. Yeah, we will compress. We will do some basic tests how to compress 1-bit images the easiest, because no, there will be also one. I'm a masterschman today. Just this is an experiment. There will be also on Wednesday. This is an unofficial, because I want to do some passion projects, and yeah, we have like 1 centimeter of snow. It's all right. Yeah, this is, wait, screen capture, whoop. I have some code where we convert. Okay, so ChatGPT did like the major work on capturing the frames, and I can show how it's transcoding. So let's do that. I resized Bad Apple to with DaVinci Resolve to like a certain resolution. What's happening right now is we're capturing all the frames and 30 frames per second, and then we have like a binary representation with like just a big array of O's and ones to play around with encode and decode, and we will implement basically the encode decode. I can maybe during the capture I can maybe show this. Is this the one? Yeah. Yes. No, 1 bit is absolutely fine. There is no way we can do 8-bit many frames in 14 kilobytes. Here you can see that's like the 16 by 15 representation. I will zoom in so you can see better. This is the difference per frame, so not much happening on frame level. So basically without any keyframes we can't afford like a missing or broken frame, but this is easier to compress. Oh really? Oh no, then also streams. Let's watch then also streaming. I will join Dan's stream right now. He streams like every day now as well. Let me check. Simple electronic. Ah, okay. Yeah, okay. No, I'm still in preparing phase. So we see that's 197 kilobytes and we have 14. So the compression rate needs to be really great, like 16:1 or something to be able to store all the frames of Bad Apple. And yeah, we can try. There is no compression. Yeah. Okay, let's see encode and decode is basically returning the bits. Now we can do some run length encoding. The thing is, I want like a compression method that fits like on one screen. So very simple stuff. What we can do now is we can do like only run length encoding here, which will be quite easy per frame. So let's do that and see what we would receive without even trying to decode it, and hopefully there is no error and we will check on decoding. And also I need something to play back, but let's start with run length encoding. So we have the bits, we have the frames. Hint. Const frame count equals bits divided by 16 divided by 15. Or let's do that. That's the pixels. Then we need like encoded is an array, and we will return encoded. And now we will try to compress it, which will be for each frame. Let f equals 0. F is shorter than frame count. We will do an intra-frame encoding. That means it will be for each frame. We'll just store the data for the frame and then move on. Now this is like let index will be basically frame times stat, and then that's where we start, and now we will encode for let p let p be p is shorter than 16 times 15 p plus plus, and now we just go sequentially compress it, and we can use a constant size for the run length. Let's start with const RLA bits, let's say 4 bits, and let's do it like C. We start always with the color, each frame we start with the color 0, and then we just store the run length until it flips. So max length shift by RLE bits and we have also the 0, which means we can like 15 consecutive, we can store 15 consecutive similar colors. So let's say not last C, current color 0, and then we will just check const C equals bits I plus P. That's the current pixel that we check. And now we need to compare. We need to also store the length. If C, if the color changed, then we store it, store all that we accounted for. So we store the bits in encoded. So encoded, push the bits, and we store for counts of bits. That would be 4. Let's B0, B is shorter than a run length bits, and we can try with different bit lengths to see what best compression we get. B++, and then we store like first bits first. That will be basically length shifted by b and 1. So we store the run length in the 4 bits. Then we reset the length, and we switch the color, which will be current color equals C. Otherwise, we length plus plus. No, we do also. Oh yeah. Or length equals max length minus 1. We can do it like that. So we also need to store it there. And then the only thing that's missing right now is, now we store everything run length encoded. The only thing missing is at the end of the frame we need to store stuff. So if len is greater than z, oh no, wait. Oh, that's interesting. We start with black. Now I need MS Paint. Okay, what happens on the first pixel? Let's assume we have pixel, pixel, pixel. Okay, so what happens here? We have, let's say it starts with 1, then it will store, okay, let me expand this. No. Maybe later. So we store a 0, then we yeah, but that's easy. Well, run length encoding is simple. Wait, so do we need to, we have 0, but we need to store a 1 here already, because we read a pixel that's already different color. We start with 0. Oh wait, only if we reached max length. So in that case, no. Also in the other case, we need to store, no, we need, that's the pixel that we currently processed already. So there will be no case in which I won't store stuff at the end of the frame. Yeah. So I have definitively to store that that here. So the reminder needs to be stored at the end, no matter what. That's it, that's the frame. Let's see how it performs. We need to... Can we do that now? That won't do anything. Yeah, I will reload it. But we can store it in web storage. Wait, here, choose file. Yeah, I need to do storage. Local storage. After I loaded it, it will be way easier to do like this local storage stuff. We can't achieve the compression we need for that. Like that we need to compress everything in 14 kilobytes. We cannot achieve that with the 4-bit compress. Oh, 0. What the? Huh? Oh yeah. Here we go. Yeah, here we go. Let me run that while we implement local storage. Okay, so frames, local storage, set item, and then frames. And we will do encode decode. Now we will do like, we only need like one button. Encode. Yeah, we'll do encode decode here. Function code decode and do the stuff that's needed here. This is trash. Oops. Encode decode. Frames equals local storage get item. Oh, that's correct. And yeah. Oh wow, look at that. Compression rate 60%. What? That's not good. Not great, not great, I'd say. Why is that so? Should we need also try to it's only like on average it's only like able to compress like 8 pixels in so Larry, Yeah, I will do something similar. We will try Octree, which is way better in compressing stuff. Cinepack? Yeah, but I need a decompression algorithm for that. So if you can provide that, that runs on this cheap ass microcontroller in real time, then we can try it. Okay, we can try local storage now. Did I save it? Yeah, I think I saved it. We just need to do it once, and then we can use the button encode to, even though if we reload, we don't need to come. Hashtag collab. Okay, let's take Discord. AZ compress, string compare. Okay. Okay, now let me reload. Oh, what is that? That looks different. Huh? What did it store? Let me check that. Ah! What is that? Yeah, but it's boring using a finished algorithm. A working algorithm is boring. We want to explore stuff, but now I need to explore why our stuff is. Wait, let me check. Where is the bug here? Local storage set item frames decode encode stats. Oh, is it a string now? Wait, it's a no. Do we need to stringify it first? Let me check. Local storage. String format, okay. JSON decode local storage, and here we need to do encode frames. Okay, and we don't need that. We will do it manually from now on. So we need to run it once more, loading the frames, capturing the frames. Four by 4 pixels. That's good, yeah. It's also so long. What? Oh, JSON stringify. Shit. Yeah. Damn. Again. It's too hot in here. Turn down the heating. I'm wondering what an improvement we will get if we only compress the difference image. We are currently compressing like all images. Oh yeah, we don't need that breakpoint. Huh? What? What is it? What is it? Parse, okay. Yeah, but we don't need to store again, so here we go. Okay, that is now we will try different bit size. Let's say 5 bits. What happens with 5 bits? It's bigger. What happens if we do 6 bits? Also bigger. What happens if we do 3 bits? Also bigger. 4 bits is like the sweet spot. Right? Yeah. Maybe 2 bits, but 2 bits doesn't make sense. That's only like 4 pixels. No. Okay, so we get 4 bits is like the optimum for the compression here. Unless we do the compression in difference. So how we can do that? This is like, can we somehow store it function? Yeah, we will do encode only the difference between the frames and check how that changes. But I guess it won't be much. This is LE, and this will be now, let's check. For encode run length with difference, we only need to check bits that changes. So const C f equals 0 will be that. Otherwise we get that XOR bits minus 16 times 15. Okay, that's basically the compression of the difference. So first frame, we assumed the frame before us was all black, so we just store the initial bits, and otherwise we just do an XOR with the frame before that. Let's check. Oh, look at that! That's not bad. Let's see how it performs if we use 5 bits now. That could help, because maybe there are... Oh, here we go. Maybe even 6 bits. So we can store like... Was it 64? 64... 67, okay, 6 bits even. But I don't think 7 bits will be too much. Yeah. But it's not that bad. I mean, what did we have? 6 bits? Yeah. 6 bits looks the best here. So we got already a great compression here with run length and diff. Should we display the percentage? We can do that. The code and compressed VR, and then we do okay. 32% to fixed. Let's do to fixed. To fixed and to okay, 33%. Or let's do to fixed 1 times 100 and then do percent here. Okay, here. Okay, that's the best, 32.9. We can probably save a little bit more if we go across the boundaries. This will be encode RLE diff or diff RLE. Difference and RLE. Now let's start again with function encode. And now do octree. Octree encoding is basically, that's what I imagine could work. I never like saw that. I mean, like JPEG, PNG always store blocks. I will show how that works. So we have, let's say, an image, and there is, it doesn't matter if it's a difference or not. Something's happening up. Something's happening here, and then maybe here is a different pixel, and there. If this, if it's a difference, that's what we saw. Like only the outer shape is changing. So how we can store it is basically we store a tree with the sections where something changes. So we have 1 bit to see does anything change in this frame. That's the first bit. So we have a 1. Then we split this image by 4. And then we have this section here, which is something changed. Then we split it by 4. Then we have something changed. It's depth first, so it depends on how we store it. But if we go depth first, we go down this route. Then we have nothing changed, nothing changed, nothing changed, and there is the pixel. Basically, we are down to 16 pixel. Then we store the next section, which something changed. Then we have 0, 0, 0, 1, 0. That will be 0, 0, 1, 0. And then we have this one, which is basically something changed. That's a 1. Oh, there is something, there might be one missing. Wait, 1, 1. I think there is a 1 missing. Anyways, here we got something changed, 0, 1, 0, 0, which is stupid. Now we compress very few. Then we have nothing changed here. Then if we compress this side, we have nothing changed, nothing changed. Then we have something changed, 0, 1, 0, 0, 0, 0. Then we have 0 for this here. Then we have compression 1, 0, 0, 0, 1, 1, 0, 0, 0, and then we have 0, and that's the whole frame. That's stored, and that's how many bytes? I guess like 5 bytes. Okay, let's see if we can. Hey, nerdy. Is my TTS? Has my TTS died, or what is it? I might have dropped out of. I can't hear it. I can't hear my TTS. Let me check. Ah, okay. That worked. Hey Tisa, you're also here. Okay. So octree compression will look like that, and we are able to compress how many bytes are per frame? We have like 2 per line times 15, or in that case 16. Yeah, 1 to 6 even. I don't know. Let's see if it works. So our run length encoding worked like 1 to 3. Now we try the compression to implement the octree. Depth first. How do we store it? That's interesting. We go down all the way, or not. It's interesting. I have no clue. We would need like to reverse it completely or something. Function R, which is basically, yeah, depth. We have X, Y, and then we have depth, and then we have, here is, that's the array where we store the bits, and this is our recursive function, and now we need to divide it. Yeah, if so the issue is, if we would have like all pixel changed, the problem is we need to store yeah, we would need to store the color that it's changed to. So if we store color or an indicator, yeah, it's solid, like several states. So we need like 2 bits per section, which is, yeah, it's like trying to reduce it to 1 bit. How much memory? We have 14 kilobytes, and currently now run length encoding was able to store the whole animation to 64 kilobytes, which is still too high. Let's try octree. We will just reduce in frame rate. That's now 30 frames per second. But if we reduce the frame rate, then also the changes will increase per frame. So not necessarily, if we reduce like to 10 frames per second, it will not necessarily end up being like only 24 kilobytes or something, probably more like 30. So let's try the recursion, and let's just start. No, we don't add anything. This is the challenge. This is the challenge to get the most out of the 14 kilobytes that we have available. Also, it's a nice practice to see what is the best for image compression with 1-bit images. Or what is the best that we can do with low effort. So we start at 0, 0. Oh wait, we can do depth, or we can just say size, which will be here 16. And then let's see what happens. Maybe encoded is here fractal compression. Fractal compression will be challenging. I mean, if you can find like in a Julia set a position where you have exactly like this shape, that could work. But then you need to store like doubles, like 4 doubles for one image, which will be basically the same size. That probably is the best for higher resolution images, like the 16 by 15 that we have here. Okay, let's check. Okay, we need max length, no, frame count. Frame count. Yeah. Let's take that. So we go all the way down. All the way down. So this will be if S equals 1 and bits y times 16 plus x plus, oh, this is now we need to frame. We need the frame, so we just steal that here, frame count, and that. We steal that part. Let's do it per frame. Oh wait, this is the function here. There is no current color, but there is this thing. Oh no. Okay. Let's use it here. We need the I, the offset. Okay, you know what? We store the offset here. Bits and offset. Okay. Bits plus offset. Okay, that will be the frame offset. So we have bits I for the offset. If the color, so if we return, wait a second, we just return the bits here. So if it will just return the color for if we reach the maximum depth. So otherwise we will do like the division. So R is basically, yeah, we call R and in X, Y, S divided by 2. And then, oh, we need also to check for the boundary since we have only Y in the resolution. But this doesn't store anything yet. This doesn't store anything yet. That might need to store something. Might need to store something in case if bit is 1. So const bit. So in that case, if bit then encoded push 1, and otherwise we return, wait, and we return bit. This is like the last level, but we also return to the level before, which will be basically that bits offset. Hello Z80. Now we need to run let's say x plus 1, then we have plus 1 and x, oh wait, no, plus s, sorry, no, half s, s hs ss divided by 2, so we split the whole square plus hs and hs. So this will be the new size, and now that's the interesting part. Let bit be 0, and then we need to do following bit or equal. We need to check if any of those returned 1. If so, we need to store a 1. And there is no boundary check yet, but we will do that now. So not really. It was really straightforward. Okay, we don't expect x and y to ever be... Oh wait, no, that's easy. We can do the boundary check in here and just always return 0. Here. 0 means nothing is stored. That's cool. Okay, if x is greater than 16, which will never happen, or let's say res, or y is greater than y res, return 0. In that case, we will just assume that's what we have. X res 16 plus y res equals 15. X res y res Apala. Okay, so now we have that here, which is basically same as here. That's it. That's the whole compression of the frame. Only thing missing here is the highest level. And the highest level will push the... No, wait. We need to store each of those... Oh, no. Ah, shoot. We store we don't store here. We don't store here. We store here each of the bits if there is a difference. Otherwise we go level up and so forth. I'm doing a mistake here, I guess. Because there is like on the highest level skipping here is important. We only don't skip if we have something here that's so now we need to store the stuff. Otherwise we return or bit 1 or bit 2 or bit 3. Only in that case we push the bits. Just copy paste it. We can do it like in a loop, but and we need to store a 1 here. So we need to store a 1. We compressed something. Compressed something and then store the bits if there was a change. We return 1, otherwise return 0, and then we need to do here as well const we just store the bit here and code that push probably that crashed. What? Oh yeah, we didn't return anything. Return encoded. It's increased in size. That isn't. Nice compression, bro. Yeah, I'm a genius. That's the best. Especially, oh, you know what? It also stores. Oh, wait. We can optimize because we need a if there is like that here we have only we store too many bits if in that case we need more, but wait, what? Did it improve? Damn. Yeah. Yeah, so oopala. What am I doing here? So and this is, we need to check for the boundaries, which is that we don't need to store any bits that are out of boundaries here. Yeah. 104. Okay, that's not that great. Now let's try with the difference image. Why is it so bad? Why is it so bad? Okay, now difference image, which we have here. First, yeah, I won't clean it up if you need to read the code. It's just an no, it's not an octree, it's quadtree. It's quadtree, and I'm you missed maybe the compression here. So it basically checks does anything happen, and then it stores a 0 here, and we have a 1 here and a 1 here, and this is 0 0 0, and here is also a 1, and here is a 0 0 0. This is what it does recursively. So it basically compresses the areas where nothing happens to 1 0. And where something happens, it goes down down to, like, here we have 1 1 1 1 1 1. Here also 1 1 1. Everything else is 0 0 0. This is how that would work. If there is only so few changes. Mustache. Yeah, look at that. Yeah, Tony likes it apparently. Otherwise I would shave it off before streaming. It was just for the jokes. It will be too annoying for too long. Let me now. Okay. First, we need to check if it's the first. So that will be f equals 0. So if it's the first image, it will just. Otherwise, it will offset. Const p equals y times 16 plus x, or opala. xres. Yeah, we can use that if we have it already. And this is offset. Okay, octree. I don't believe that will work. Xres time yres. Xres. Wait. Here. Huh? Nothing changed? For the diff? What? Seriously? Uh-oh. That's not good news. Huh? What did we have before? We can check that by true. It's the same. What? Wait. 4.4. Huh? That's improbable. 875. It has to have some. No, it can't be. Something's broken here. Oh wait. I don't use C here. Shit. This is what we need. Yeah. X, Y. Yeah. That's why I don't see a change. Uh-huh. Let's counter. No, wait. That's still true. There's no difference. There was a bug. It's more like 20. $8.25. Huh? I'm really confused now. Bits I. It's the offset. Oh yeah, we don't pass it down first. Yeah, that's the issue. We don't pass it. Ah yeah, we are back. 875, yeah. Huh? Oh yeah, that's the compression with difference. And this is without. So it does something, but run length encoding is better than that. So if we do, this is the difference, 22.5%. That's quadri compressing the difference, which is not that great. I thought it would be better. Do we need to do a binary tree? Let's do a binary tree. That is encode quad or diff quad. Now we encode and we will do a binary tree, which is basically... Oh, I need to pee, sorry, I'll be back. Okay, back. Somehow I can hear bitluni again. I don't know what's happening. It broke. I missed all the... No. Okay. All right, peeps. Also, watch on Twitch to support me there. Okay, it's working for me as well. Yeah, binary compression will be could work better if we compress like half. So we see, okay, there will be. How do I clear it? Yes, dual streaming. Come on. Okay, so let's say we have blah blah blah, and then this is our image, and we do it like that. We divide it first like that. Okay, we have store 1 or whatever, divided then like that and that, then divided like that and that, like alternate all the time, and that. This way we have to split the probabilities a little bit more. Otherwise we have a chance 1 to 4, no, 4 segments can mess up our compression. In this case only like 2, so the probability is changed, but we need to store as x and as y here, and we will do as follow: if as x and as y equals 1, then we do This can stay. This is X. All good. This is the same. Now we have if Sx is greater than Sy, do the following. Else do that. So that will be H as x divided by 2, and then we have just the two segments here. X, and then we have H as x, as y, as x, as y. 1, 0, and we take that bit 0 and 1. The first one, will it be stored? I don't know. It should be completely clipped. No, the X, the first one will always happen. Okay, so coded push bit 1 H as X is shorter than X res, and push bit 1 return 0, which will be here. That's basically all. And we need the same for Y. Y, copy paste code, nice. Y. Y. Thanks. Fun. It's good, isn't it? H S Y H S Y offset bit first. Y res X Y. Okay. Is that it? Szymanski, yeah. X res, Y res. Oh no. Oh no, we need to compress whole 16 here. Otherwise it won't divide really. Okay, let's see how that compresses. Our current Quad3 benchmark was 22%. 31. Phew. Then. Oh no, Quad3 was better? Yeah, if it compressed, then it compressed like, oh shit. That's terrible. And that's already the difference. Run length is scored the most so far. Damn. We have now 4 different compression algorithms. Run length encoded, difference run length encoded, difference quadtree and encode difference KD. Yeah, or binary tree by. We'll call it diff by. Okay, what encoding? What else do you want from me, peeps? Should we explore more of the run length encoding stuff, or what was the what was the other stuff? What else do we want to try? We're now 1.5 hours in. Tried several encoding algorithms. The best one is so far run length encoded with 6 bits. So this will be function code that only worked for this was our best. What was the quadtree again? Plus run length encoded. How does that work? Okay, we have. Oh wait. Not binary. We wanted the quadtree. You know what? I do it like that. Function encode diff quads bits. We always assume that that it's stored correctly. Oh wait, that's better. What? Quadtree is the best so far. 22%? What? I thought run length was great, but it seems like now the quadtree with difference is good. Wow, okay. That's interesting. So we had fractal compression mentioned before. Encode, let me check. Diff run length, yeah. Yeah, it's certainly quad difference quad is the best so far. But only at this frame rate. If we choose a different frame rate, it won't work anymore. So we need to reduce by another factor of 4. That's impossible. What did you hear? I'm wondering if you invert you can always, I mean, let's look at the compression. Let's assume we have like changes, whatever, changes everywhere. Ah, no, we can't invert it. I was thinking what happens if we just invert the image and just store one bit at the beginning of the image if it's inverted or not. If it compresses better inverted, we could do that. Otherwise, self-similarity, that's recursion. Imagine we have something like that. Oops. Divided. This is the image, and then we have like here, there is some odd thing, or here is something going on. Then this whole image will store, let's say, okay, it indicates it's 1, and then we have like 4 segments, and this is, let's say, 0, 0, no, this is 1, here we have 1 pixel here, 1 pixel here, and this is a 1, and then it divides again, and this is 0 and 0. Yeah, that's the difference. I'm storing only so the quad-3 compression has 104% without the difference, and if I use the difference image, which is XOR, that happens. I can show it to you. That's here basically. So if it's not the first image, it does an XOR. So first image assumes it's always black, and then otherwise it uses XOR with the previous image, which is in that case the difference. So self-similarity will be, we store for this level, we store 1, 1, 0, 0, and then for the next level it can be basically the same. So that will be recursion 1, 1, 0, 0. Which is, instead of saving, if we have like a dictionary and let's say we store, we use like 2 bits. This is the entry 0, 0. Then we have entry, I don't know, whatever entry. Let's assume this is that, and this will be, let's say this is 0, this is 1, depends on the probability. Then we have maybe 0, 0, 0, and we have 1. And now we can use like 2 bits instead of 4 here, and then the whole image will compress way better with like 0, 0. Then we have 0, 0 again, and basically this whole section is already stored, and we have also 0, 0 here, and then maybe something else changes 1, 1, whatever. That will be recursion on its automatically recursive if we would use some kind of dictionary there. But for that case, we would need to, we have don't care values as well. So this is our stuff here. So we could use a dictionary for storing those bits here. But like in GIF or a GIF, we would need like to build up the dictionary first, which is terrible. It takes a lot of memory and computational time, and I'm not sure if I want to do that. GIF, yes, with double F. GIF. So better run length encoding. I don't know if we can improve on run length encoding. the quadtree stuff only works on images because that assumes what else we can do is the following. We can use octree encoding, which will be more sophisticated. You have like, we have now, whoops, we have now, this is one frame, but we have also the z-axis, which is basically, you can assume we store each chunk of 16 frames. We store each chunk like in one section. So we will then subdivide like this section and this section. Since we have some similarity, I mean, we use now the difference. But if there is something only changing in one section of the image all the way through, then we can compress better like this whole stuff. We can use just 1 0 for 8 frames here. We will compress, like, if nothing happens, for 8 frames in this box with the octree. We will store an 8 by 8 by 8 cube with 1 0. Imagine that. Should we try to use octree? But I will calculate the difference first. Otherwise, it will be really nasty. Yeah, I will calculate the difference first, and then, oh wow, and then we will do the whole X, Y, Z stuff. And we have also don't care values, which will be basically 0. Okay. Div quad and div octree. This is the last thing that I will do for today, and then we will call it a day, which is already okay. Encode div octree, which is I assume it's on. Ah, shit. How many frames? Oh wait, frame count. Zres as frame count. It will. It's so complicated already. Oh, I hate it. Ouch. Okay, we will start at. We need to do the whole thing for all the frames plus 16. Oh yeah, that could work. Okay. Since we start with resolution 16 and then, but we need also zres here. Zres const zres equals okay, frame count. So if f plus 16 16, otherwise it will be f minus frame count, because we need like to accommodate for the last frames that are not dividable, like the count. Frame count minus f Okay. No, that's all right. If f plus 16 is shorter than... No, shorter equal, it's all right. Zres, and Zres is here. Push the bit XYZ as the start. Hey, Rota! You have missed all the fun already. We have a result. Run length encoding was like 32% and this is now quad-tree compression, which compresses to 22.5%. That's like we need 44 kilobytes for the whole animation of a bad apple, which is still too big. And now we are trying to do an octree compression, which also takes like the time into account. And we are already working on the difference. Broccoli. Yeah, yes, that's bits. Let's also change the bits to difference. Maybe we should do it here. Damn. Const diff. Oh wait. Bits d. Difference and then bits and xres and ys. And we do a difference function. Diff, then we have x, y, b, and we have const f equals b divided by x times y. That's the count of frames. Oh wait, we don't need that. For let I equals 0, I is shorter than b length, I plus plus, if I is shorter than x time const r push, and then if it's shorter, then we just do bi, otherwise bi I or I don't know if we need that here, bi minus x times y. Okay, that's calculating basically the difference bits d, and then we don't need to do all the first stuff. We just do the bits d here. And this also can directly return here. Simplifies this a little bit. Okay. Yeah, we have x, y, z. S bits offset. We don't need that. But now it will be complicated because we have two slices. It could be time for converting this to a loop instead of trying to like copy paste it. What do you think? Frame count encoded x zeros. Oh yeah, there is the zeros now, and we need that. I zeros. Or z is greater than zeros. Plus x res time y res time z. Do we copy paste? Yikes. Okay, let's just copy paste it. 4, 5, 7, and then we have Z, 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 and now Z plus H, Z plus HS. I'm wondering if this does anything, or if it's increasing the size. I mean, if we can, if 8 frames, if something changes in the quadrant of 8 frames, then the whole quadrant is messed up. Will I put the code on GitHub, compress 17 frames into 9 bits for each? What? Why is TTS? I can't hear it. What is with my TTS again? Maybe when one part of the image don't change, there is code that you don't use. Next can be used the same many times that the block don't change on the next 16 frames. Yeah, that's the octree. Put the code on GitHub later. Yes, I can, but I need to move the repository somehow, I believe. I can live share it right now. Make read only. What is my live share stuff here? Live share. What is the how does that work? Shared servers. Shared. Copy link. Invite others. Okay, here we go. Here is your live share. Here. I have a Polish TTS. Okay, You can just clone the code right now as it is, even on the fly. Why I'm changing it. Okay. Push bit 4, 5, 6. Oh, really? 40K. Wait, is this the complete didn't we get something similar? Okay, 44. But it's quite similar with really not much effort. I'm wondering how good we can compress this one here. Like if we could even make it like lossy compression, but on diff that won't be nice. With diff we need to like maintain the error and then imagine we have like only 1 pixel changing of a whole quadrant. We can like throw that away and just maintain the error for the next frame to make a lossy 1-bit compression. That could work. In that case, we might be able to even like compress it further down, like to, I don't know. But it will look shitty. Did you, Christian? Let's see what is the entropy. Did you calculate the entropy? I'm wondering. We can try that. I mean, you dropped the file on Discord. That should be the. Oh no, that's. You storing the 8-bit version. I need to drop that one and see if we can get what is the size that we can compress it realistically with WinRAR or something. Free version of WinRAR. So we have like an upper limit. Yeah, I hate these pop-ups here. How do I turn it off? Here. Yes! I turned off the notifications. Here we go. We used the live share yeah, because I forgot how it works. If z plus hs is shorter than zres, that's what we need. Okay, I guess that's already it. That octree didn't seem that much bigger. Okay, let's see if we can what we can compress. 44. Wait, what? No, we didn't plug this in here yet. I put it down because we have all the. That was the quad tree difference and. Now we will do oct. Moment of truth. Is it buggy? Does it compress at all? Ah! What? Out of bounds? What is the issue? Huh? What was the of undefined? Huh? Bits D is undefined? Huh? Do I need to make it var or what? Bits D diff. Oh yeah, we're not returning the here return. We're not returning the difference. Really? We just treat time as just a different like a dimension of space. 14%. That's amazing. Now we would need to check if it even decodes. Yeah, I would need to write a decoder for that to see if it actually works. 27. And we can store 15 frames. Oh no, 15 frames per second won't compress as well as this one here. If we use like half the frame rate, it will be worse. So maybe we can store the whole thing in 10 frames per second or something. Imagine that. 27 kilobytes. What? It has to be broken. It's broken. Most probably. I can't imagine that's real. But actually, if nothing changes for 8 frames, it's capable of basically compressing them into 1 bit, like one section, 8 by 8 by 8 pixels. If nothing nothing happens in the whole frame, it even is able to compress 16 frames of nothing happening, nothing changing, to 1 bit. This is... I don't believe that. I don't believe that. I mean, we got like 22%. It might be. It might work. Okay. Not that bad. Let me try now dropping the file. We have this file dropping here. Convert to video frames, download binary. I can do, oh yeah, this converts the bits to bytes and stores to a file. So we can try to do the following. Wait, init, now where is it? Decode, we can store the file, download binary, and then we do basically frames. So we can try the zip thingy. Okay. Unconfirmed. Still downloading. What's going on? Why is it taking so long? It's strange. I think the antivirus is bad. Okay, I try 7-zip. Okay, here we go. 7-zip does 30 kilobytes. Can we do... Wait. Oh yeah, I can do that. I'm not sure if it's... I15 raw 1 bit. Yeah, let's try highest compressions. Oh, what do we want? What do we want? We can do not schnell, ultra. It's just a format, huh? Compression, deflate. Deflate 64. I have no clue. Yeah, 36. Yeah, that doesn't look good with that. I assume we are close to entropy. How to calculate the entropy of a file? With 30%. Oh, that's not the difference. Wait, that's uncompressed. That's basically like our run length thing. No, not even that. That's not the difference. We need to compress the difference. Let me store the difference of the frames, and we have 16 by 15. Okay, that will store the difference file. I can also upload that. And we need to compress that one because the entropy will be... Will it be different? I don't know. Doxing myself again. Here we go. I will upload that as well. I'm not sure even if the diff works properly. Yeah, I will use 7-zip ultra awk. $30 kilobytes. Nah, we are close to entropy, I guess. How do I... Is there an online calculator? Ah. Which order are they? Bit 7 of the first byte. Oh, first bit, like first bit is like the first pixel. Second bit is second pixel, and so on. It's not like or like flipped or whatever. The order is like always. I'm not sure if how do we calculate the Shannon entropy? Oh, we need the probability. Oh. Where's the data as Markov process? Ugh. Ah. There is an entropy JS that can calculate it. And there's a lot of code to just drop it in my stuff. Wait, this is entropy and there is like a Shannon entropy. What's the difference? Eight four. No, wait, reduce. No, that can't be that this is the code. Here. And this is of a string. Yeah, I don't know. I'm almost exhausted right now, so I'm not sure if What we can do is we can write a decompression or an algorithm that displays that renders what we want to be sure that everything we are doing here is correct. First of all, we need to playback. So on init, I would do start or playback. Playback. Window. Set interval. Interval time handler is playback. And then we have timeout is what is the frame rate 30? That's 1000 by 30 milliseconds. Playback, and playback will be function playback. If frames, is frames here? Yes, it frames is here. If frames then yeah, playback frame. Okay, const frames. Oh, fc or count. Const count, or is this like a keyword? Alright, let's do that. Frames length divided by 16 times 15, and playback frame equals playback frame plus plus, oh, minus minus, whoops, times equals C, that C playback frame equals 0, and then we will show frame. Show, no, there is no show frame. Draw frame. Frame data bits, any frame data bits is frames, offset any, yeah, if not C. Frames data offset is basically playback frame times 16 times 15, and then ctx frame in, put image data 0 0 frame data. So now we will have some sort of real-time playback here. Oh yeah. Oh, I need to kill that download thingy. Download binary. That needs to happen on a button. At best, put image data. That didn't work. Huh? What's the issue? frame data, data. What's the matter? Oh, what? It's different way around. Okay. Here we go. And then 0, 0. Okay, this is the one that we are compressing. And now we need to deflate. Which will be difficult. Unless we undiff. Oh wait, diff does XOR anyways, so diff, we just diff and then we are good again. Okay, so let's try decoding something. Sorry for doing stuff here. Let's try with diff, or let's try only RLE encode. Encode run that. Voila. And then decode will be decode RLE. Let's start with that, and then we will see return. Oh. And then we will see encode decode, frames decoded. This is what we need to display then. So we will do that here, frames decoded, playback, if frames decoded and frames decoded length only in that case, who knows, maybe there is something messed up. Only in that case we want to also show the decoded frames. So we will do, yeah, draw frame and show it. So put image data, context frame out. Oh yeah, draw frame data, and this is not frames, decoded frames, or frames decoded. Here we go. Okay, so we will show decoded frames. Now we only need to do this run length decoding here. Decode RLE bits max length. Okay. I don't know even if we need that frame count. We don't need that. And then we need decoded, and that's quite simple. So let b be as just bits length b++, and then we have or let's do while let b equals 0 and then while loop, because it will be less messy. We can control like the how many bits we take. Oh no, we always take the count of bits. Oh wait. That's interesting. Plus equal. In that case, we have always the rung length bits here. So we start with, oh, and now we have the frames. Shit. The frame always starts with 0. Oof. Ah, okay, yeah, current color, we can switch it here. Okay, so len now let's for I++, and then we have len or equal 1 shift. No, wait, that's not I. That will be bits b plus I. What's wrong with that? Oh, there is already? Oh yeah, we have that here. Okay, no worries. Yeah, we just throw this whole trash away. And then we have 4 len I++ decoded decoded push current color and then we have current color flip the current color, and then we have if decoded length, shit, modulo 16, 15, then we set current color basically to 0 again because it starts from new frame, and that should be all with decoding RLE. Okay, let's see. Okay, the decoding didn't work. Decoding of the RLE didn't work. Yes. Okay, that might or might not be an error somewhere in there. So what's the matter? Who finds the bugs first? The bug first. Highest significant bit. It stores. Okay, max length. Oh, interesting. Yeah, there is a bug in the run length encoding. Shoot. It would need to store like a 0 if we continue with the next one. ChatGPT. Yeah. Okay. Okay, this run length encoder isn't it will be worse like in the compression rate. Because currently if we run it until the maximum length, then it will basically if not current color. Oh shit. If we continue with like oh, that's diff RLE. Okay, decoded RLE, encode RLE. Let's make just 8 bits or 7 bits. Should be less errors. Just check that. Nope. What is... There's a fly. What is going on? What did I do wrong here? Decode, encode. Shift right by B and 1. And it's basically shift left by I or I have no clue. Okay, that was a little bit less successful, but what we can do now... Wait, what do we return here? Aha, what is that? I don't know even where did it take the decoded from. Where does it take the decoded from? There will be errors, but frames decoded, decode. Oh, all right. Okay, that's now still. I'm hungry. I need to quit for now. I will stream tomorrow again. No worries. Encode, decode. Ay. We can do maybe the quadtree decoding. What do you think? Quadtree decoding? Oh wait, I need to change that. I want to change that to this diff thingy. What? Oh. Without this first thingy. And I hope and this will be that. Const bits d, and then we have bits d here. Encode diff quads. Let me check that. Encode diff quads. Diff. Oh, I encoded it again. Nobody said anything. It was like double encoded or what? Yeah. It seems to work until the first flip, and then the first appearance of white breaks it. Let me check the decoder again. Decode. Encode decode. Oh, that's a bug. Okay, that's what I expected. That's the run length encoding, which basically breaks because it doesn't store the color. Okay, this will also break with 4 bits, which was the best method here. Yeah. That's the only bug with the run length encoder that I implemented. It's more or less okay-ish. Okay, now the quadtree. I have no intention of repairing the encode div quad decode div quad, which will be basically frame count doesn't matter, decoded, so it's depth first, which is not good. We need to change the order of the algorithm, how the algorithm is storing the bits. So what we need to do is, this is all right. This is the right order. But then everything that happens in there needs to be like a different order. So we might need to wait, this is the decode. Like create new arrays here. Return 0, return 1. That's the array. And here we do array equals, oh no, we need, shit. How do we do this? Or do we return arrays here? Am I even still live? Everyone signed off already. Okay, I return an array here. And that's okay, that's bit. Basically, we assume we have, it's always the first bit that's telling the compression. So if we return this array, then we can create. Oh, that's nice, yeah. Thanks. Oh, nice, for some free batteries. Encoded, we don't do encoded. That's basically R equals that. And then we do R here and then return it. No, this is R append. Wow. How do we concatenate two arrays? Concat? Yeah, concat. That's that. Return 0. Okay, now we're working with arrays. And then we'll everything and then encoded will be basically concat bit. This will be storing the frames. Strange, but it might work. Okay, let me see if it still compresses. Nah, it breaks. Where does it break? Is this decode? Decode, yeah, I need to do this decode. Yeah, we'll change that stuff here. Decode, yeah, F this. And there is no this here. Okay. It's just okay. Oh yeah, that was the uncompressed. And why is the compressed broken? What? Why is the compressed broken now? Let's see. Encode div quads. Let's put it here. Huh? Oh, wait. It creates a new array. Oh, that's the wrong one. Then we need to append something. Splice or something. Let me check splice. No, it's not splice. join. No. No, it creates a new array. Okay. Then let's do that. R oh yeah, and this is encoded. What is that? Oh yeah, quadtree. 18%? That's like really strange. That's different than we had before. Now what is that? Oh no, is this thousands? Millions? No. This is strange compression rate. All right. I think I will call it a day. It's 6 o'clock. We can stream tomorrow, or should I continue? You decide. Yeah. Try again. It's so slow with creating all the new arrays. I hate it. I hate it already. I would rather like concat it to attach it to the there must be a better way of just adding the elements. What is sum? Unshift with those supply sorted reversed. Yeah, but push has like you cannot if you push B. Oh wait, you mean operator dot dot dot? That's interesting. Yeah, that could work. That's like a special thing. I never used that before, but I know that could be a thing. Yeah. Okay, let's do that. And also we can avoid that one already. It unfolds the whole array? Yes. As parameters, is it? Does it? Yeah, like as arguments, I mean. Yeah, let's try that. That should work. Should work faster. Where are we? Spread operator. Very. Now still took some time. Did I save? Yes. Spread operator took also time. Strange. Yeah, it creates all the sub-arrays. Still. Damn. It might have helped a little bit. And now I'm confused about the compression ratio. Maybe our diff thingy is broken. I have no clue. Anyways, we can decode it now. So if we have bits pips. Decoded for while shorter than bits. Oh no, what? Offset. Offset shorter than bits. Length do the following. If R, yeah, let's do R 0, 0, 16 bits it's 16 by 15. Oh, the MP4 is 256 by, where is the file? I can maybe share it with you. And did I share the MP4? MP4. Here. Yikes. But it can be any size because it's scaled to the canvas anyways. And the canvas determines the size. Oh, come on. I hovered over the wrong folder. Now it's trying to open the network folder that's not available. Terrible. Okay, let me do this. Bits. Shoot. No, we don't do bits. Bits. The let's deck here. I dropped you the original MP4 on Discord in lab. The decoded will be new array, and that's basically 16 times 15, which will automatically fill it with zeros. Deck and then bits, and then R will basically check. Offset, no, this is deck. If if bits offset otherwise, if not bits offset, then return. Then if S is equal to 1, then do the following. Then we do decoded x plus y times 16 equals that, otherwise yes, it's only one bit. I mean we could expand it later for whatever, but we have 14 kilobytes of flash on this device here, and we want the whole thing. Okay, now if we see offset here, then we have offset plus plus. Wait, we can here. No, let's do here. Offset plus plus and then return. Return. What? The code editor. Oh yeah. I do that so people with mobile phones can still read it. Offset plus plus. So many lipos, nice. And then we just do R and then do Y const sh as bits and decoder bits decode. So here it took as an indicator there's something changing. There is the last bit. Oh yeah, also if now this is all right, bits decode sh. The decoder is quite simple. That's basically it. If x plus sh shorter than xres, do that, because otherwise we didn't store anything. And y x and y plus sh shorter than as bits decode, and the offset should be increased here all the time. And that's it. Decoded needs to be, oh yeah, we need to decoded or decoded, push, deck. That will attach it, and then we need to return diff 16 by 15 decoded. Okay, decode diff quad should work. If not, I don't try. Forget it. It crashed. What is wrong here? Undefined. 10 megabytes, no, 100 megabytes of undefined trash. Why? Oh, yeah. Deck is not decoded. Wait, where are we? We pushed decoded to deck, deck to decoded, so we appended it. But there is one issue though. Yeah, that's why it's... Wondering what's going on here. Okay, this bit is handled here. Wait, we can do the plus plus here, and it's definitively 1 here. And there needs no offset here. And this has already happened. And then we have... Oh yeah, this is also plus SH. This is plus SH. SH. This is plus SH, but that doesn't matter really, because that's only the target. Wondering why this doesn't work. Starts with 16. Then bits and decoded. Should we step in all the way? Let's start here. Encoding. Okay. Function R16 array. So Oh yeah, that's necessary. Oh yeah, 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 yeah. We have like black frames in the beginning. Yeah, the coding works. It totally works. I see it. If I squint my eyes, I can totally see what's happening there. Okay, let's try removing the diff here. Just decode it. And the encoder should also not diff it. Bits gleich bits. Okay, let's encode it. It will be now bigger, the file size will be bigger than. Oh, there's some bug going on. I guess I got. I guess. I guess this might be the issue here. The ifs, that tries to skip the last parts. Wait, this is div quad. Let me try doing that. But this will mess up the whole image. We can see it. It's just moved a little bit. Oh wait, yeah, there's a delay. Yeah, what happens here? What happens here is we skip the last row, and now that somehow is badly compressed. I need to pee again. It's cold in here. I need to turn up. I'll be back in a second. We can fix that. I like Bad Apple, the wrecked Bad Apple, better than the original one. Okay, let's disable this condition, which makes the file a little bit bigger, but decode. Oh, this is the error. Okay, I know the error now here, but I need to fix that here. I need to test it first because we have some conditions where we cancel everything. Did I press? Yeah. Decode. And here you go. Now it will work, but actually yeah, that's 87%. Let me check with diff. Oh, diff somehow didn't work properly. What's the matter, baby? Ah. Oh no, I don't know. Wait, no. Yeah, it works, but why does it show the diff? Huh? There is like a flip somewhere. No. Yeah, but that's 18%. This is only the quadtree. It has a bug. Yeah, but does it work like that? If I decode, it XORs the frame before that. That will be just another different. Yeah, that's the actual. What do I do? What do I do wrong here? I need to. Undiff it. And the diff Let's undiff. Because we have uncompressed frames here, and I'm comparing against the against the difference, but I need to I need to do this. It was too fast? Trust me. All right. I like that. That looks like somewhat of a compression. Now let's fix the box where we store like the last row that's not needed. That will bring us down to the 14% again. It's not Wednesday. Jeopardy. Yeah, I know. That's lustig. That is lustig. Okay. You're doing now everything with ChatGPT. I mean, it helped a lot in the beginning. Now, maybe ChatGPT can do like a 1-bit a nice compression method for 1-bit arrays. Okay, let's fix our messed up ifs here. So Kevoli, you need to wait, I will fix that for you, but let me do that first. Push. Oh yeah, that's all right. No, this is still messed up. Let me fix the playback for you. Frames decoded. So how that works is you need to choose the file, then it will store it in the local storage, and then you need to encode. This should work. Hey Sniff. Well, I think I will quit now. So I'm somehow lost here a little bit. Yeah, but it also started quite early, so that's also illegal. X plus HS. y plus hs yeah. This is what happens when I'm not stressed. You know what? You know how I do that? I will do the following. Push, push, push. And then in the decode, I will only do if y this is like this special case. Let me just check if that changes anything. Yeah. 18% still. But then the compression worked or what? They are a little bit in the past, huh? Okay, 80% with quadtree. Now we would need to convert it to octree. But I am too lazy now. I will quit it. I will call it a day for now. And that's the quadtree compression. It somehow works. And the octree was even better. What was our octree compression? What was the rate? Encode diff. It won't decode properly, but 14% was the octree compression, which is even better. So we are getting closer there. I will think about, we need a decompression for that as well, but I will think maybe of a method how we can even improve on that and then see what happens. I will be back tomorrow. I don't know, at some time, maybe at 5 o'clock or something in the evening. I'm happy to see that actually that it's not like that's actually able to compress like with we have a real compression here with the quadtree already, which is at 18%. So it could be realistic that the octree is able to achieve the 14% that it claims. And this is better than zip files and any other compression already. I don't know if animated GIF would be more capable. But this is already really nice. GIF is compressed, but it's lossless. GIF. Okay, so peeps, you can think of maybe nice methods how we can still improve our methods. What I'm thinking about now is we start with the octree being like or the quadtree like that, which we start like the whole segment. What we could do is try like to we tried like to split it in half always. That was worse. Maybe we should try to split it like in different, but this is stupid. And we have already 4 by 4. Yeah, like this might be that saves up. Would that be better? Let's think about. Let's think about if this would be better. Or we skip the first levels. We always assume the first level is a 1. Hey, Enric. But that only saves 1 bit per frame at most. So if we assume like the first 2 levels are all 1s, that would be 5 bits per frame. How many frames is this anyways? Does anyone know how many? What is our? What's the frame count, peeps? Let me check. Playback. Oh, what is that? Oh, that's in the middle of some. I just need to remove that. Sorry. 6573. 65. Let's calculate. 6573. Okay, we have 35,398 bytes divided by frames are 6573 equals. Okay, we currently need 5.3 bytes per frame, which is amazing, and we could only like save up with skipping a few levels of the quadtree. We only be able to save like 5 bits, which in that case is maybe 10% of what we are doing right now. So it would be lower to like maybe 30k, which isn't like a huge jump. There is one thing that I can think of. Currently, if we split like a frame here and we have like a 1 here, and then we store. So there is always this 1 that indicates we have 4 more bits. And then we have like 1, 1, 0, 0, or whatever. And I'm wondering if we can like sort that by probability. So if we can store something like we can use either we can use the 1 and then the next bits will be of variable count, and like really rare cases will be like where we have all ones and we use 5 bits for those. Let me show that. So we have something like 0 never happens. So that's the one thing. If we have the 1 at the beginning, so the first bit indicates, then we have 0 never happens. So we can skip that already. But we have, because in that case there would be a 0 here. But then we have the case of, let's say, only 1 bit is set, which in the difference image with lots of frames, like that, it's not. Hofmann encoding. Secret engineer, take the file, the binary is in the lab, and compress it and tell me what you get. Because we used WinZip or 7-zip to compress the raw binary, and it was only able to achieve like the same what we are achieving with that. It's the same result, but we have an algorithm that compresses even further to 14%. So actually we're with the quad tree, which is not optimal. The octree is more compatible, more better. It's like what was the compression rate? Oh yeah, let me fix that also. That was quad. The octree, I think we checked it. The octree was even better than zip. Here, this. Yeah. No, it's very special. So we had a compression of 27. We tried different compression algorithms, 7-zip, like deflate and so on, and we always were above 30 kilobytes. And with the octree compression, we don't have the decompression algorithm yet, but this is like the best one. What I'm thinking of right now is if we can do like a table here. Let's say we have all the cases where only 1 pixel changed, stored in 3 bits. So we have that. Then we have that. That will be 0, 1, 0. Oh wait! 0 is missing. Okay, let's do it like that, and 0, 0, 0 is basically that. And then we add like 1, because that would be probably the most common cases. We can analyze that. We can try different tables, and 1, 0, 0, 0 will be basically something like the 2 changing bits here, and so forth. And we might end up with, yeah, we will end up with 5 bits as well. So that's like some sort of give. We have like a fixed dictionary. Oh, we build it up? No. Should we count the probabilities? Wait. Yeah, I removed that one line. There was like a one stray in playback. There was like a stray frames decoded here. That line needs to go, like line 52. Cavoli, you can remove that one. That should fix that. Okay, yeah, octree. The decoding of that. The octree decoder we will do another time. I will go now and I see you tomorrow. You can still access, I will leave it there. You can still access the code with the shared logic gates. Yeah, you mean, huh? I'm confused. Of course I like logic. Okay. Here. This is now the 18%. Okay. Okay, here you got bad apple in 18%. Interlacing? Yeah, I mean, we can just halve the frame rate. There will be a way we can store like everything in 14 kilobytes, but really we need like to go down to maybe 10 frames per second. And then a lot will change in 10 frames per second, so the compression will be worse because we do diff compression. The diff makes the biggest difference. Puns intended. Or now I'm curious. I want the stats. I want the stats, peeps. Let's do the stats. Shall we do the stats? Let's calculate the stats. The probabilities for certain I want the probabilities for function p of frames. I just want to know if we can pull something off with the probabilities of can we just, how do we, yeah, we can just drop them in log console log p, and we will return and we will have like block count. We have block counts. Yes, on my Discord in lab. Link bitluni.net Discord / Discord is the Discord, and then we have like the binary, the difference file, and the original MP4, and also here you got the share, live share. How do I? Live share. Where do I get the, you can get the code from the live share, and I don't know where to, where did I get the live share link? Copy server URL, here you go, ants, have fun. No, that's not the, that's the wrong one, sorry. Sorry, that's the wrong one. No, how do I, yeah, here we go. Here is the link. Block count, and then we have counts new array 16, and then we will calculate basically the 2x2 blocks of for x. Oh, we have the issue that no, function picks bits frame x, y, x res, y res. Oh, let's do bit here. Oh, what is that? Zero x shorter 16 x. Oh no, +2. We want 2. We want 2x2 pixels, and then we do the following. Const index, we can do ei, upsala, const I. Oh wait, I can check in as well. Is this published? I have no clue if this is published. Const I is basically bits that's missing in that one here. Oh yeah, frames. Then we have x, y plus 0. Let's start with that. Um, 16, 15. Let's get a new line here. Plus, oh, let's do that. So we make the that will be, we make the index out of the bits, and then we have the index, and then we will do counts I plus plus. So we will just count the counts, how often we get a certain 2x2 caret, and if x, where is the frame? Oh, we need all the frames as well. For let f frames length divided by 16 times 15 f plus plus. That's also the frame which we need here. Frames, frame. Okay, if x greater x res or y is greater than y res, return 0. And that will happen more often because we need to clip at the bottom this one row. So we will have certain odd probabilities, but yeah, we have just to consider that. Else will return bits frame times x res times y res plus y res times x res, y times x res plus x. Thanks. Hey there, green. Okay, so that returns a bit, otherwise 0, and that should give us the counts of the bits. So let's check and see. It will drop in the counts. Oh, it dropped the function. Block count frames. Yeah, okay. Local storage, yeah. You just need to choose the file once, and then you don't need to get the, oh, not a number, what? Huh? I thought an array is filled with zeros. What is going on? A monocle. Hey, isn't an array filled just with zeros at... Where is it? Where's the counter? Let's check. Empty times 16. What? I thought this was always like initialized with 0. What the F? Yeah, that's not good. Okay, let me... How do I initialize? Fill 0. Oh, wow. I need to fix that in any place where I... Oh. Yeah, see that now. That could have been like strange results at some point. Oh yeah, uncompressed. What does console say? Oh, look at that! The probability distribution. Certain constellation. Okay, we have zeros that obviously zeros happen quite often. Then we have constellations like all ones, all zeros happen quite often. Then we have like the corners. And something like 9 or 6 doesn't happen often. We should do it on the diff. Let me do it on the diff. Because we need the diffs. Frames, diff. That's what we actually compress. So that should be already a little bit... What's Eh? What is the error? Oh, yeah. Ouch. Ow. Ow. Something happened with my leg. I don't know. Okay. The diff does. Okay, here we go. These are the... We have many zeros. This is why we compress so well with 18%. This is all skipped, more or less. Now, if we see, we have high counts on stuff where this is like 1, 2, 4, and 8. That's what I drew here. I assumed that most likely we have stuff like 1 of 4 pixels is set. So we can do a dictionary that actually compresses, instead of 4 bits for cases like that, we can use maybe 2 bits. or okay, 2 bits is 3 bits, which already saves like 1/3. And then the not the really rare cases like these here can have the lower. Oh, that's cool. That's cool. Okay, I assume. Let's check what the probabilities are here. So we have, or let me get something like a notepad. Here we have something like that, yeah, it's almost the end of the stream. You are dismissed. Okay, we have 5, 4, 9. We can maybe calculate the probabilities of that. 0 is skipped. So this is how often, let's say this is how often these cases happen. Then we have cases like with 2 bits, where 2 bits are set, are more like 1,900. So half as probable are cases like that. Is that also? Wait, this will be 10. 10, yeah. All the cases with 2 bits set are most probable, more probable than the cases where we have only 1 bit set, 1 bit not set. So this is less likely. Are this all the cases here? 6 cases? I think I'm missing something. 4, 500. That will be basically 1. Zero, 2 bits. Yeah. Yeah, Hendrik, Happy New Year. So 0 is compressed away anyways. Oh, if we do like a basic compression without the quadtree, so what happens with the quadtree is that if all are zeros, we only store like 1 0. So that is compressed away in basically 1 bit. So we don't look at the case of the zeros, only at the ones, but ones are very rare because we store the difference, and there are rarely a case where the whole change or a complete fill is flipped. That's only like the edges of the shape are changing. So most of the time it's only 1 pixel in a square of 4. This is 4, this is 6, so 10. And then we have the case. How much is the case? Okay, 1171 is the case of all ones. All ones. And 386,000 we have the other case, which is not stored. So this will have the most bits. And this will be 3 bits. This will be 3 bits. 3 bits. This will be 5 bits. No, this will be 5 bits. 5 bits. I don't know if we fit that. 4 bits. Let's try 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Then we have 1, 0, 0, 0, no, 4 bits like that. And then we have 1. It's a hard-coded table. One, 1, 0, 0. I'm not sure, that won't work anymore. Yeah, that won't work anymore. That case won't work. Oh, wait. That's the count. And the 5 bits, yeah, that won't work. That will be, now I need to do some. Yeah, no, the prefix. We have. No, but we need the prefix. Otherwise, we don't know that it's not like the second one. So there is always like you cut the range in. Yeah. So that's also the problem here. We have the prefix here 1, and then 1 would be already 5 bits. So there is the issue that we have like, yeah, that will already be like some cases will of 2 things will be already 5 bits, otherwise it won't work. Okay, but I think I will think about that. We can save like 1/4, and we can even calculate what the savings would be right now. Since we have the probability is here, we won't save 1/4 because we increase those, but like 1/5, maybe 20%, maybe 15% we can save using like this lookup table here for the last bits that are stored. In the quadtree. That would be another of 35. Yeah, that would be down to 30 kilobytes, which is making it already so complicated. I don't know. The compression algorithm for the quadri is already really cool. I like that. Decode quadri. Yeah. It's just like this writes a 1, otherwise everything is 0. It fits on one screen. Alright, I'm gone, peeps. I see you tomorrow. Thank you for tuning in. Thank you for the lurkers. Don't forget to also tune in on Twitch to push my numbers. That helps. Google fun product, computer engineering. Okay. Yeah, peeps, check that out. What Henrik tries to promote here. But I'm off right now. Bye bye everyone. I see you tomorrow. I will be streaming around 5 o'clock. See ya. Who raid? I don't know. Oh no, I forgot to raid. Alright, next time. Tomorrow then. Shoot. Where's the streaming stuff?